Welcome back to the C++ Bootcamp. Last time we left off right at the point where we had two additional operations that we needed to fill in before we could say this particular version of the solution for palindrome detection is working. We did the simple case where we just had the word. We did the case where we had case difference. Now we're going to go ahead and handle the case with spaces and punctuation marks. So where were we? Now, we had remove punctuation, but we did not have remove spaces. So let's do this. So remove spaces. And we already have remove punctuation. So what is it going to take for these to work? Now, passing in a string and removing punctuation from that string, what we don't want to do is, let's see, so we have this complex case here. If we have something that looks like that, we need to handle that case by doing both operations. So we'd get rid of the spaces and we'd get rid of the punctuation marks before we do the lowercase and before we do the reverse. So removing spaces would turn that original string into something that looks like this. So red rum, sir, is murder. Something like that. And removing the punctuation would, of course, make the string look like this. Now, order of operations doesn't really matter, but because we're talking about it in the context of I started with this string, I removed spaces, and then I removed punctuation. Now, the general idea here is we're going to end up with another string in both cases. So it's just like when we took the original string, we did a lowercase, and then we took that string and we did a reverse. We're going to have to allocate space for these strings to make the removals happen in a way that's clean. So let's see, removing spaces is going to almost look like any one of the two operations we've already done, but let's think about this one a bit. So we know we want a string without spaces, and we know we have the original string. So what is it that we want to do? Now, we still want to do the length calculation. We still want to do the allocation of memory. And let's say we call this no spaces string, because I can't think of a better word. All right, and let's see. So no spaces. So we would say 0, j is length. We do something like this, but now what we're going to do is say I is the index for the spaces, the no spaces string. And j is going to be the index for the original string. And the reason we're going to do it this way is because, let's pass this guy out too. What we want to make sure of is that we remove the spaces, but we don't want to try to be too tricky. I don't need to pre-calculate how many spaces I have. I just want to remove the spaces so that the resultant string looks like this. So what we're going to do is for each character, if it's not a space, we're going to just write it out, right? Once we get to where we have a space, we're going to skip writing the space into the new array, into the new character array. And then we're going to just continue on about our business. So it's going to look something like the following. So int I 0, j is also 0. And while j is not equal to the length of the original string, we're going to continue in both cases. And we're going to say if the, okay, so we need something we've already done. Where is it? I think it's the, not the palindrome, it's the, we did this when we were trying to, lowercase. Yeah, it is lower. All right, so we need this kind of conditional here. So we're going to say, if we end up with a case where the integer value of the string, and we're going to use the j because j is the index for the string, if that value is not equal to ASCII 32. Now let's remember, what is that ASCII? So ASCII 32, that is the space character. So if we have an integer that's equal to the space, well, if we don't have an integer that equals the space, let's make sure I have enough parentheses on both sides, then we're just going to copy. Otherwise, we're not going to copy. But what we're going to do is we're going to increment that value. So doing it that way allows us to deal with the fact that we have spaces in our string, but we're going to intelligently deal with those spaces by simply moving the index of the string ahead by one value. So in effect, like we did here, we said not a space, so copy, not a space, so copy, not a space, so copy. Here's a space, let's skip it. And then the next location for the new array would start at that character value. And then we'd be good to go. And that's what should happen here when we're trying to remove spaces. So, yeah, that should be exactly what we're doing here. So if we're not dealing with with a space, we're just going to copy. Otherwise, we're just going to move the index of the string here. And actually, that reminds me. So what that means is I need to set the index for the new string and set the value for the index of the existing string. But on the next step, I don't need to always move my index for my original for my new string. So if we don't have a space, then we're going to set the value at I, and then we're going to increment that index. If we do have a space, then we're going to increment the index for our existing string, but not increment the index for our new string, so that we don't have any spaces or holes in our character array for the new string. So let's see if this works. And let me set a breakpoint so we can watch it work. And also, let's see, character pointer, no spaces. Remove spaces from some string. So we're going to remove spaces from a string. And what's wrong here? Value const char cannot be used as slides. Okay, so what am I returning? Oh, right, because I'm modifying, I can't do const char. I need to do a char star. And the reason that it's not going to be const is because I want to modify that character array. I'm passing out something that I'm going to modify in the future. So when I define it here, I don't say const because I'm going to change the actual character array in the loop. And then when I pass it out, it needs to be a char star because, again, I'm passing out something that I'm going to modify. So remove spaces, so we get the length, we remove the spaces, that gives you no spaces. We lowercase, no spaces. We reverse string the lowercase string, and then we figure out if we have a palindrome. So let's see if this works. Now we did rev string, lowercase string, and I guess we would then do the no spaces string to balance it out. All right, so rev string, lowercase string, no spaces string. And then we return palindrome. So no spaces string is what that should be. All right, now we've got a good build, so let's see. We want to test that that works, so we need to use this string as our test case. So let's do that and remove our extra double quotes. Do another build. Okay, so now, if we start our debug, let's see if this works like we expect. Well, of course it won't be palindrome yet, so I'm removing the spaces. I haven't removed the special character, the punctuation. We just want to test that that first piece works. All right, so length, palindrome, and now we're going to step in. So set the palindrome, set the length, do the no spaces, hopefully it doesn't die. So string, the length of some string is still 23 because we haven't modified it. So no spaces string is going to get some space. Okay, so now let's use the watch. So if we remove that value and remove this value, but we add our no spaces string, if we add that array entry and we use the right indexes, so right now it's going to give errors because we haven't gotten to that part. And let's see what happens to I and J. Okay, so we're about to go into the loop. Okay, so now they're initialized. So now I is 0 and J is of course 0. So that first value is not a, yeah, so see it's R. So if you look here, you'll see what the array value is for the existing string. And if you look here, you see what the value is for the new string. So because we don't have something that's a space, that first location is going to get filled in, and I and J will both increment. Well, actually, I take that back. What happened? Oh, yeah, okay. So now it's going to increment. Because what's going on is this outer for loop, so between here and here, J will always increment. And we're trying to make sure that J always increments because J is the index for the existing string. Our string that we passed in, which is the red rum sir is murder. So We need to make sure that we account for every character in this string, but when we get to a space, we're going to skip and not fill in the location in the new string. So we'll go through a few of these because red is not a space. So now we've come to the first condition that's going to be equal to 32. So what you're looking at here is the character value and then the decimal version of that character value. So because we've got a 32, we're going to hit the else case and skip that location. So J moves forward, but I did not move forward. And that allows us to fill in the new array with all of the non-space characters from the old array. So if we remove this breakpoint, put a breakpoint here at the end and hit continue, then our no spaces string is just like what we thought it might be. But let me see. Oh, so something happened with some of our characters here. So let's see. So the original Red Rum Sir is murder. Okay. So when we got to the space, what happened? All right, so now we do need to look back at this. So it looks like we'll have a part 3 of this one because the next case, well, the next case should be easier, but we're going to kind of do the same thing when we remove punctuation, but spaces should also be their own function because you're doing these, you remember I said function composition where we're going to apply different operations. So we start with this original string, we remove spaces, we remove spaces, we remove the punctuation marks, we're going to perform lowercase, we're going to do the reverse, and then we're going to check for palindromes. So that's 4 different functions that need to happen. But the operations are done in order so that the transformation gets you to a point where you're ready to do a simple comparison like what we did with Madam or race car. All right, so let's do a restart. Okay, well, yeah, never mind. So I just need to start from the beginning. All right, so we've loaded this up, and that looks right. So let's continue, and it's going to stop at our first breakpoint. So I should be able to hit continue. Okay, now it's in the function that we need to actually debug. Okay, so I is 0, J is 0. J is not equal to length yet. Let's keep incrementing J. I wonder. I think. Yeah, all right, so let's check this now. So if we set the breakpoint here, hit continue. Okay, so when the index for the existing string is 3, the value is a space. And that matches because if you think about the 0 index, so 0, 1, 2, 3. So when I get to this space, I should skip to the next thing. And that's what I'm doing, but the problem is what? What do you think this is? I give you 5 seconds and then I'll tell you what the answer is if you don't, and then we'll see if you're right. So think about it like this. The for loop is already incrementing J. Anyway, it's going to do that no matter what. And I'm also trying to account for it when I run into a space. So I give you 5 seconds and then I'll tell you the answer. Okay, so if you guessed that this additional J is messing up the index for the original string, you're correct. Because this for loop is always going to increment J, I don't need to do this additional one because it's going to make me skip past characters I actually want. So let's stop debugging. Let's get rid of this condition. And then what will happen is anytime we run into a space, we just won't add a value. So if we put this breakpoint here, just to double check that what we've done will work, we'll get a little bit of confirmation. So now let's start the debugger. do a continue, do a continue. All right, so now no space. All right, yeah, so that's what we expect. Space is gone, value is still intact. And the length is 23, but actually, it doesn't need to be 23. It needs to be the length. It actually needs to be the value of I. I'm sorry, because I is the index for the new string, and at this point. Actually, let's see what that value is. And actually, I might be gone already, so let's not do that. Let's say, so if we initialize I out here, then we allow ourselves to not lose that variable, because what will happen is if I initialize I in the for loop, it'll be gone when I leave the for loop. That's what's called a scope. Scope means what I can see, like a telescope. So in a for loop, the things I define in the for loop's initializer are visible in the loop. Outside of the loop, they're not visible. So because I want I to be visible outside of the loop, I want to define it here, use it in here, and then have it as a value out here. So let's set that breakpoint. We'll save to make sure we don't lose our changes. We'll do a rebuild. And we will debug to double check. Okay, so continue, continue. Now the value of I is 19. So at I, it's equal to nothing. If I look at 18, so no space at 18, I should see the last character. Okay, so this is correct because I'm not going to chop off my my value here. And then no spaces string, see, it looks correct now instead of having all the extra stuff at the end because the character array didn't have a proper 0 to end it, a proper null byte. So okay, so we can stop the debugging here. This looks okay. This. So now all we need is to remove punctuation. And removing punctuation is going to, it should consist of, all right, so let's talk about what that is. So now that we believe our remove spaces works. Looking at removing punctuation really just means anything that is, at this point, not a, let's see, how do we do this? So that I don't have to have that many conditionals, and the order in which I'm doing the transformations. So let's see. In order for palindromes to be detected, I'm removing spaces, I'm doing a lowercase, and after the lowercase, I think that's where I need to do the remove. So no punctuations. Okay, and then we have lowercase string. And then we can type of construct, yeah, right. So remove punctuation. Where's that guy? Oh, there it is. All right, so we need this. And then we need this. And by the time we get to this point, let's do a copy, make sure they're free. So rev, punctuation, lowercase. Don't know why I copied all of that, but that's okay. So we'll do this. And Now let's put the logic in. And the reason that I'm doing it in this order is because I only want to have, if I did the punctuations before I did the lowercase, then I'd have to have more conditionals when I do what I'm about to do. So removing spaces was all about knowing that we are trying to condition on something that's not a space. So we only fill things in that are not spaces, right? So no punctuations, string. Whoops. Let's do that a little neater. So no punctuations, no punctuations. So it looks almost like no spaces. So no punctuations is like no spaces with more conditions added. So no punctuations. Why are you being right? I want that string here too. All right. So instead of just conditioning on it's not a space, what we really need is, because we've removed spaces and we've already done a lowercase, the only thing we need to do is make sure that we've got lowercase letters. So let's see. All we have to say is this. If we have characters that are between 97 and 122. So 97 and 122. If that is true, then you write it. Otherwise, you don't. I think this is it. We already kind of figured out all the logical shenanigans with the other function that removes spaces. So let's see if this does what we wanted. And when I was talking about this at first, I didn't think through. I only wanted to have that one conditional instead of having to think about uppercase and lowercase. It's only as long as you got lowercase characters, then write those out. I believe that is all we need to do. So now we shouldn't need, well, we don't need that anymore. But now let's put a breakpoint here just to double check our work. And then hopefully it just works and we can handle all the cases that we were talking about. Okay, so we continue. We continue. So no punctuations is, that's not what I wanted at all. All right, so this is only 6. Okay, so what happened? Stop debugging. It only took the first word. Okay, so now let's see what happened when we actually came in here. Oh, okay. I think I know what happened, but I won't make you guess this time. But let me see it in action. All right, so Rev Rumster is murder. Yeah, so anything that's not okay. So if it's greater than equal to, less than equal to, that should have worked. All right, well, let's see what happened then. Yeah, that always does its thing. That's there. Okay. So not equal to length, get length some string. All right, let's see what length is. Actually write it out this time. All right, length is 19. That's what we would expect. So, all right. Okay, some string is greater than or equal to 97, less than 122. All right, that's correct. So remember, what we're trying to do is look for when we get to that question mark, when we get to that comma, what happens? Okay, so let's keep going. All right, and now we're at the comma. So now it's not greater than 97, and it's not in between 97 and 122. So what happens? All right, so it keeps going. Right, so why is this not doing? Huh, that's weird. So j is 0, j not equal to length, j plus plus. When it hit the comma, it stopped doing this piece. So what did I not do correctly? All right, let's restart it so I can see it again. So continue. All right, let's see. Length, I is 0. Huh. So this is greater than or equal to 97 and less than or equal to 122. Okay, yeah, but it did do that. And no punctuation string is, yeah, okay, that did it. It just looked like it didn't work at first. Okay, so then we go here to the next piece. All right, once we get to the comma is when we see strange things take place. Oh, you know what it is? It's because I am erroneously using the index I. And you probably already knew that. And you were like, man, when are you going to figure out that that's what's wrong? Yeah, that's what'll do it. That will do it every time. And it's because I used the conditional from the original function instead of remembering and updating it. And it's because index I is for our new string, index J is for our O string. So that's why it didn't do what I was expecting. And I was not changing anymore because J was being used like I. So my mistake. Okay, so now that we have that working, we ought to see when we do this debug that it'll work like we expect. So continue, and now I ought to see, okay, yeah, Rebum serves murder. All right, cool. So then if I, let's see, do I have one at the end? I do. So if I continue and look at the output, oh, why not? All right, we're almost there. Let's see. Why not? Oh, and it's because no punctuation string is not used in the reverse string. So I have to remember when I make these kind of changes to propagate all the changes appropriately, because we started with some string. Some string turned into no spaces string. No spaces string turned into lowercase string. Lowercase string turned into no punctuation string, and then no punctuation string turned into reverse string, and we use this reverse string to figure out if we've got something that's a palindrome, because we compare it to, oh, and that won't work either because the reverse string now needs to be compared to the no punctuation string. Otherwise, it will still say it's not a palindrome. So now that we're not using lowercase string, because lowercase string was right before the step where we took out all the punctuation. And because we're reversing the no punctuation, we have to compare those two together. So now let's see if we get something that works. And if this works, then we're where we need to be. And that's not that bad. It took a little longer, but you know, hey, that's what happens sometimes. All right, so let's see. Let's see what we get. Oh, still no dice. All right. All right, well, third time's a charm, I think. So, all right, we know that this worked. But now I am curious. Why won't because the length can't be based on the old length. Now it has to be based on the new length. So, let's see. What we need to do is, now that we've done the no punctuation, we need to calculate the new length. So the new length has to be based on the length of the no punctuation string. So, and the reason why that is because the old length had a lot more stuff in it since we had spaces and punctuations. But since we've taken out the spaces, taken out the punctuation, we need the new length. And not only that, we need to use a new length here so that we're not using the old length where they would never match up. So let's see if fixing that actually gets us to a place where it works like we expect. Because I think we're close, and it's just a matter of getting rid of all the little silly bugs. All right, and there we are. So we were able to turn this with spaces and punctuations into a single block of text that we could then check to see if it was a palindrome. Not too bad. Not too bad at all. And now that wraps up this particular portion, video, lecture, whatever you want to call it. I hope you've been able to get something out of it. And if you find that it's helped you in some way, don't forget to hit the like button. Don't forget to subscribe if you want to see more content. I'm going to continue to add videos that deal with specific solutions as well as the C++ language in general, because we're working towards enough familiarity where we can start to do Win32 API kinds of stuff and system level things. So hey, if you bear with me, I mean, you'll be able to get to the more advanced things in due time. Thanks again for watching, and if you have any comments, please do not hesitate to put them in the comment section at the bottom. And thanks again. See you guys later.